Hey there! So today we're going to do something that's actually pretty cool. We're going to turn math into pictures. We're taking concepts that have an infinite number of answers and figuring out how to draw a single, simple image to show all of them. Yeah, let's dive right into graphing simple inequalities.
You've totally seen signs like this, right? At an amusement park or something. It doesn't mean you have to be exactly 48 inches tall. Nope. It means you can be 48 inches, or 49, or 55, or even 72 inches tall. This whole idea is the world of greater than or equal to, and it's the perfect example of why just one single number doesn't always tell the full story. So here's where it all clicks. An equation, like x equals 5, is super straightforward. It's got one solution, 5. That's it, one single dot on a number line. But an inequality, something like x is greater than 5, well, that could be 5.1, or 6, or 600. It's literally an infinite number of answers. So the big question is, how on earth do you draw infinity on a piece of paper?
Well, we do it with a secret weapon, circles. And seriously, this one little rule we're about to cover is the absolute key. If you get this, you can graph any of these inequalities correctly. It's the most important part.
Okay, here's the rule, and it's actually really simple. If your symbol is just less than or greater than, you use an open circle. That means the number you're starting at isn't actually part of the answer. But if you see that little line underneath, for less than or equal to or greater than or equal to, you use a closed, filled-in circle. Here's a trick. Think of that extra bar in the symbol as the extra ink you need to fill in the dot. No bar, no fill.
All right, theory's great, but let's actually do this. We're going to walk through a couple of examples together, step by step, so you can see exactly how this works on a real number line.
First one up, x is greater than 2. Okay, step 1, find the number 2 on the line. Easy enough. Step 2, look at the symbol. It's just greater than, right? No bar underneath, so that means we draw an open circle on the 2. And finally, step 3, where are the numbers that are bigger than 2? Well, they're all to the right, 3, 4, 10, a million. So we shade the line to the right. And that's it. You're done.
Let's try another. How about x is less than or equal to -1? First step, find -1 on the line. Got it. Next, check the symbol. Aha! See that little bar for or equal to? That means we use a closed, filled-in circle this time. Last step, where are the numbers that are less than -1? That's going to be -2, -10, -50, all the numbers to the left. So we shade to the left.
Now for a little pro tip. Sometimes you'll see one written backwards, like 3 is greater than or equal to x. It's kind of confusing to think about, right? So here's the secret. Just flip the whole thing around. If 3 is bigger than or equal to x, that's the same thing as saying x is less than or equal to 3. Just don't forget to flip the symbol too. Now it's a piece of cake. Put a closed circle on 3 and shade to the left because it's less than.
Okay, so now that you know the rules, let me give you a little insider knowledge. I want to help you sidestep the two most common mistakes people make when they're first learning to graph these.
First, it's super easy to mix up the circles. Just keep that trick in your head. The extra bar in the symbol is the extra ink you need to fill the circle. The second mistake is shading in the wrong direction. Now, a lot of people see that the inequality sign kind of looks like an arrowhead, right? And that trick works perfectly, but only if your variable is on the left. If you have something like 5 is less than x, the arrow points left, but the answers are all to the right. That's exactly why our flip it rule is your best friend. Always get the variable on the left first.
So we can draw these things, but who cares? Why does any of this even matter? Well, let's bring them back to the real world, because this visual language of more than and less than is absolutely everywhere, and a lot of the time it's keeping us safe.
Just think about an elevator. It always has a maximum capacity, right? Let's say it's 2,000 pounds. The weight, which we can call W, has to be less than or equal to 2,000. It can be exactly 2,000 pounds, which is why you'd use a closed circle, but it absolutely cannot be more. This isn't just a random math problem, it's a safety system that we rely on.
Or think about a bridge on a highway. To make sure trucks can pass under safely, it needs a minimum clearance height. We could write that as h is greater than or equal to 14 feet. Any truck taller than that can't pass. This shows how getting that symbol right has huge, real-world consequences for engineering and, not getting the top of your truck sheared off.
So the next time you see a speed limit or a weight limit on a box or even the character limit on a text message, you'll start to see these invisible rules everywhere. So my final question for you is this. What inequality are you following right now, at this very moment? Think about it. Thanks for tuning in.